Hi everyone. Good evening.
Good evening.
Hi Radhakrishnan ji. How are you?
Yes, fine.
Great, great. Okay. So yeah, I think people are still joining, but we will start considering no need to wait so long.
Yes, yes.
Let me share my screen. Okay. Mhm. Can you see my screen?
Yes, sir.
So, good evening all once again. So today I'll be more focusing on NIME in life sciences. Now, tell me a difficult situation where you have to do multiple calculations using different software for the same project. For example, you have to take from uh, drawing software, draw the structures, take it to Autodoc, then dock it, then take it to PyMol for visualization, and then for MD simulation or something, take it to some other software, or to predict the chemical properties, you have to take it to some other software again. So have you ever faced these challenges? As usual, our rule is yes for one and no for two, like that, or Y or N. So I have you been using multiple softwares for the same project? Or so you have not used much software for your projects. Even for the experimentalist, you might be using statistical tools. You might be using Word, Excel, right? So have you used multiple softwares for the same project? I don't see anything on the chat. Yeah, yes. Okay. How do you think that if we can automate that? For example, taking input from you, then it runs on a particular software or does some analysis, take the output and take it to an input for the another software or some other analysis, and it goes like a workflow one by one. And in between, you are not doing any job. You're making it go automate it one by one. So you are not sitting in front of the machine to automate it. So that is what we are trying to see with the software called as NIME. NIME is a requirement now, like for computational chemists or even for biologists, bioinformaticians, whoever are applying for jobs. This is something like Excel sheet, knowledge of Excel sheet for people who learn statistics. So this is one of the mandatory things now. This is one of the slide deck I have given because I am being training NIME even at NIME conferences. Like I give lectures and guest talks and case studies even in NIME conferences for the past 12 years. So I'm being extensively using NIME so far. All the NIME workflow examples you can find in hub.nime.com. So you can create an account there. It is like GitHub. So it is like a GitHub for NIME. As usual, my technical slides are all there in SlideShare, even for NIME. My case studies are there in YouTube. I have around 3 to 4 training videos of NIME in it. And you can download the workflows and notebooks of what I have developed or generate in GitHub. Now, let's see what is NIME and other stuff, okay? So NIME is an analytics platform, which is different nodes and workflows. Let me just take, sorry, yeah. Yeah. So it is like it has workflows, it has analytics, reporting, automations, integrations, and parallelization. So it can take input from you. It can do several kind of tasks as well as analysis and gives you output. The same way, whether the task configuration is configured or not, whether it is configured, whether you have given proper parameters, whether that particular job is executed or not, whether it has some error, these all can be displayed, and this is called as traffic lights, which tells you the status of that particular task. Similarly, this is how a simple workflow looks like. I'm taking an SDF file, I'm running it through a file converter, and then I'm generating all possible conformers. So I'm generating 3D conformers of the structures that I've given. And then I can able to look at different SIP, like SIP means P450, metabolic stability can be analyzed. Even conformers or different smiles, all different file formats can be done. At the bottom, you can see a very large workflow where we are doing a machine learning modeling and then we are deploying it because developing QSR models is click of a button, but you have to deploy it to make useful for other novel molecules to predict properties. So in that way, we need to segregate as data access, transformation, analyze and data mining, visualizing them, and deploying them. Then only others can make use of your models. So this all can be done with a single click. Of course, to build the workflow, it's not like you need to spend some time. Some sense has to be put in there. But then once it is done, you're just giving your input file, maybe SDF file or anything. Just click a button, you get the output. Multiple tasks will be done on the downstream, right? And multiple manipulation can be done on the data. All those things can be taken care of. There are a few input file readers are there. So there are several file readers, as I said, the traffic lights, right? So into mark, exclamation mark, yellow, green, this all tells you different meaning, which I'll be discussing in the next few slides. Now let's go through the interface. This interface is something called as old interface or classic interface. The new interface looks like this. Okay. So the new interface looks like this. This is something that you also going to see. Yeah. This is how you're going to see your new interface. But then whatever I'm showing you in my slides, it's an old interface. I personally prefer the old one, but for you, I'll go with the new one for the beginners. So how to go to the previous one? Go to menu and click saying that switch to classic user interface. When you click on switch classical user interface, then it will go back what I'm showing in your slide. It will take some time. So I'm just closing them. I prepared some workflows to show it to you. Did you manage to install the software? Whoever has a laptop or a computer. Oh, great. Don't install all the extensions which I'm going to show you. Install the extensions which is only required for you because it will eat up a lot of space. So why to simply waste your storage? So which I'll tell you in a moment. Anyway, let it save. I'll come back to that later. So this is the classical interface. So you have all your file management like your file explorer, or we say workflow explorer. So that will be on your top and left hand side. Then you have a workflow coach, which tells you what are the possible next node that can be used. Then you have a node repository where you can bring all the nodes which can do several tasks, including file reader, column filter, row filter, CSV write. All this can be taken from this particular node repository. On the right-hand side, you have a description. When you click on a particular node, it explains what that node actually does. What are the parameters required, like input and output? That all comes over there on the description. On the bottom, you can see an overview. So this is like a Google Map overview. So you will get a full workflow map here. And then this is the workflow editor where you can zoom into particular region and then edit them. And there's a console which tells you if there's any warnings or any errors. These are all being clearly given on the console. The good thing is two main things. If you have any task that is not there built by Nine developers, you wanted to use something external. Let's say you want to use Autodoc 4. You can use it. So your external binaries could be integrated. And let's imagine you have a lot of Python scripts or a lot of Python packages available. The Python scripts can be also integrated into uh, 9. So 9 can be like an internet browser, like for you, a browser for many tasks that you can automate it. Now we are talking about agentic AI and all. This is my agentic AI back 12 years back to automate workflows and tasks. So a bit more description. So how do you put this into it? So you click on a particular mm, node, you click and drag and drop into the workflow editor. And that's where when you drag and drop, you get to know what is that is for. I mean, the file reader, what is input, output. If you scroll down, you'll get to know all those stuff. You can also annotate your node saying that, which I'll be showing in my next few slides, how you can talk about those. And also, for example, if you're bringing in column filter, as I said, there will be description. And when you double click on each of the node, you get some parameter or some options that you can set for these particular node. But each node will have different parameters. It depends upon what is the function, what is the task that you are carrying out. And you can always save. So this green button is to run your workflow, and zoom in out in order to arrange your workflow or align the workflow in a proper manner. These buttons are used, these align buttons are used. And then you can always save your workflow in a particular name pattern. Now, another one key important thing is that how to understand where to open or what is the path should be given. Let's imagine I loaded an SD from my downloads folder and I'm sharing it with, let's say, Dr. Ankur. Ankur is trying to run that particular workflow. It will fail. It will give error that the workflow is not able to find a file, which is like C downloads Giri. Then I gave a file like drugdiscovery.htf. So that is a file. So when I gave it to Dr. Ankur, he's trying to run that workflow from his machine. It will give an error, the file not found or directory not found, because in his computer, there is no directory called C Giri, downloads Giri. There is downloads, but Giri is not there because it will be under his name or some different name. So in that case, if you want to share your workflows with other people or your team or your group, it is always recommended to use a relative path. So when you say input location, there are few options comes in your input when you try to give. So there is current mount, current workflow data area. Similarly, this is what the exact example I told you earlier, that if I am giving my path from my hard disk, which is a local path, the same workflow will have error in your machine. So you have to load your data to it in order to avoid that error. I just gave a simple example. There are many cases where we might require this file when you're sharing these workflows. Maybe not just the input, maybe other supporting files. This is where you need to give something called as workspace relative. What relative means the path before that particular file is standardized with whomever. So we have something called as workspace, which I'm going to show you. This is where I'm going to stop and going to show you that. So we need to define a workspace. Let's imagine you are working with year 4 B.Tech biotechnology students to teach 9. So you have a workspace for year 4 because there are different workflows. It is messy. So you want to categorize them. That is one workspace. So that will be main workspace. Under that, you will have several projects. The same way for year 3 also you have another workspace. So another year 3. So year 3 under that there will be several projects. So when you open year 3, you won't have access to year 4. When you open year 4, you don't have access to year 3, vice versa. So we need to maintain that workspace. So whatever files you're saving in that particular workflow is relative to that particular workspace. Any workspace you take it. So that path is irrelated. So that's why here you can say dot dot slash that file. So this works even when you share with a group with students where you want. So before that, let me go into the software. So this is what I was telling you earlier. Like if you are going through a classical interface. So if I'm going for new and I should click new and go on. But before that, let me go back to the modern UI. Let me close and open it again. Just a second. I'm trying to open. Yeah. So I will open 9 now. So just opening like the way you're opening, okay, first time. So when you open the 9, it will ask you where to create the workspace. So it will load for some time, depending upon your speed of the machine. And then it will ask what workspace to create or what is the name of the workspace to be given. So you have to create in documents, don't create in downloads, don't create in desktop, create in documents, give a name so that it will create a folder. So that folder is a workspace. And the good thing is you can always change this workspace whenever you require. You can create new workspaces whenever required. Okay. So this is how it works. So I think it is now asking for me to select the workspace. Let me check. Yeah. So it is here asking that. That is why it was not showing me. It is asking for the workspace now. So if I want to create, I can create a new browse and create a new workspace. This is my existing workspace already there. Users, Giri Bio, documents, workspace. I can even create a new one. That's all possible. So since it is already the workspace is there, I'll just click on launch and the software will open. Yeah. The software is just, it's still opening. Yeah, let it open because I have my workflows and also that's why it is taking time to load. That's absolutely fine. Oh, you're not able to see my screen? I've shared my entire screen.
Yeah, it is shown. Yeah, it is visible.
Oh, okay. Okay, perfect. Okay. So another one thing, let the software load. It is loading. As I told you, you have to go to Nime Hub. So Nime Hub is a place where you can find all repositories and examples for all the Nime related workflows. So let me show you the home page. I have my own repositories and all. So here, if I come and I search for QSAR, you have QSA model readers. There are QSA workflows. People would have worked on tox alert skin sensitization. Even I have also created a workflow like this. So this you can directly download and use it, right? So that's the best part here. So they have used certain nodes and node features. So you can have tox alert smarts filters here. So there are plenty of other related, even some other softwares will be the auto QSAR is here, and 3D QSAR is there with MOE, and even freewares are also there, like ML based QSAR. You can search them, so it is always there. Okay. So this is what is with the Nime Hub. You have to create an account, then only you will be accessible. It's free anyway. It's not. Now let's go back to Nime. So now the Nime will open like this way, right? If you want to create a new workflow, you have to always click on this create new workflow. So if I click on create new workflow, it will ask for a name. So I'm going to give DSR 26 and give create. So this is what your left-hand side. This is your central region is called a workflow editing area. So now let me go through this. In the info, you can give about what this workflow can do. That annotation really helps people when you share this with others. Notes, you have all the list of notes available. You can always change the way the notes to be seen. You can see as tree. So tree will be looking like your older style classicals. I like prefer this because it's more categorized based on the way I want it, right? Or if you like the new way, you can always list all the notes, and this way it's also good. The good thing here is if you click on this,
No, I think the interface is not visible.
oh, uh, I'm sh oh no, oh sorry, I don't know. By automatically it is changing the screen share. Can you see the whole screen now?
Yeah, it
Yes,
is
sir.
visible now.
Okay, okay, thank you. So, so basically, if I want to say that Excel reader, I click, drag it, and drop it here. Now the workspace editor is ready. Now, if I click on this and go to info, I can read about what is this Excel reader is about. I can know what is the expected output. What are the options inside this file? All explanations are here. So you need not to ask anybody. It is already there. And if you double click on it, it will get a dialog box to ask you from where you want to get your Excel file. After loading Excel file, a lot of manipulations can be done on the transformation, changing file name, changing column name, everything can be done within this. I'll go through that soon, but before that, I want to show you something else. Now, we are all talking about AI everywhere, right? Everybody now using LLMs in your day-to-day life. I came to see that many of the students are now using LLM instead of um, Google or any search engines. I would request everyone please refrain from that because search engines are different, LLMs are different. LLMs can give you errors. LLM can give you wrong information. So please be mindful. But this is good for people who wanted to start. So you have something called as Nine AI Assistant. It is a you should have Nine Hub account. So now let me show you how to install this. For example, Dr. Ankur and others have installed it, Nine, but they might not see this one. So let me show you how to do that. So first you have to go to menu and then you have to click on install extensions. Let it load. So install extensions will come. In the install extensions, you just type AI. Yeah. Under the AI, AI and space, I don't know why it is slow. There is something called as 9 AI extension. Just click this and next and install it. And you have to restart it. So after every extension install, you have to restart it. This is one option. Then, if you want to look at other 9 extensions, for example, if you're working on bioinformatics, if you want to look at high content screening, like image analysis, or if you want to look at mass spectral data, like LCMS data management, if you wanted to also look at OpenMS data, like 2D and 3D visualization of the spectrometry, those things can be done here. If you're working on drug discovery and other things, you have LASA, where they have some nodes for model building. You have a lot of chemistry nodes for property calculation, clustering, confirmation generation, and many others. And Varnalis is an interesting node where you can download PDB, you can extract properties of PDB, and Campbell data can be extracted. Many things can be done here also. So if you want to install any of these, you have to select them and then click next and finish the installations. And again, I will tell you, you might think that, oh, why should I do this? I will click everything and install everything. It will take 8 GB, 10 GB of your hard disk space. One. Second, the time taken to load your KNIME will be minutes and minutes because it has to load all these extensions when you're opening KNIME. So be mindful, install only the extensions that you really require. Don't install everything. Okay, so after the installation, you have to restart KNIME, then it should show up in your node. Now let me show you how the KNIME AI assistant works. Which nodes I should use to add missing values in my Excel sheet? I just asked a natural question, right? But of course, you should have the node over there. So it is saying that you can use missing value node, which allows you to specify how to handle the missing node. First, read your Excel file with Excel reader and then connect the missing value. So it guides you how to or which node you have to use because you don't know which node is there, right? But it can guide you. So what I'll do is I'll click here and drag and then take off my mouse and then I type there missing. They ask to add missing value, right? I click on missing value and then you can manipulate your data here. Of course, I need to have input data in order to do that. There's another way also to do this. You can go to the build mode. This is question and answer mode. There is a build mode. And now I am asking, I wanted to analyze SC, ZE, both are fine. They are US and uh, British or Indian spellings. So I wanted to analyze the data from Excel sheet with bar plot and scatter plot. So I'm trying to say I take input file and then I want to analyze my bar plot and scatter plot. So it will try to search for nodes what you have already installed and it will automatically create the workflow for you. So you saw that, right? I hope you saw that it added these two by itself automatically. I didn't do anything. Did you get how did I do it? Or do you want me to repeat it? Please be interactive. I'm not seeing you. There are 20 people and everybody's keeping quiet. That's bad. Anyway, I have to continue because you can watch the recording. So now let me delete all this and I'm going to ask something scientific. create a workflow to read SDF file and calculate properties using RDKit and plot them using histogram for molecular weight. Let's see if it builds it. See, here it is saying, I was able to find a suitable node for plotting all this. This likely means the required cheminformatics extensions are not currently available in your environment. I wanted to purposefully show you this. So I have not installed RDKit in my environment, but it literally tells you, even though you ask, it will literally tell you, please install this RDKit from your install extensions, and then it should work. So that is a support you get from that. So make sure that you install this AI assistant so that it can help you at each stages to begin. And this feature came just maybe 10, 12 months back. Before that, and only you need to learn all the nodes to understand what to use, what not to use. Let me go back to the slide now, which we are going to focus more on that. Now, let's explore what are these science-related extensions and what are the other science-related nodes. So as I said, you have to go to the three dots and say install extensions. You can install bioinformatics, cheminformatics extensions and all. And then you can always run it on the background. You can also show the heap size, which tells you the RAM that is utilized by KNIME. Sometimes it will be slow if you have a lot of data. You can always increase the RAM size in an INE file. If you know how to do it, do it. Otherwise, just leave it. Now, these are the different life science extensions in KNIME. There are cheminformatics extensions like RDKit, then Varnalis, CDK, Earlwood, Chemaxon. Chemaxon is paid, so it is not free anymore. LASA is free. Then there are chemistry nodes. There are bioinformatics nodes like NGS analysis, phylogeny, sequence alignment, sequence comparisons, and many more. And there are a few more toolboxes of NGS. Then again, LCMS and mass spectral data can be also analyzed. There are a lot of nodes for that. And HCS, which is for population analysis, screen mining, and it's all for high content screening. So these all nodes are freely available within that. There are drug discovery nodes, as I said. So whatever I've shown here now, these are all freely available, free of cost. All you can use it. But there are other nodes also available, but you need to have license for them. You need to have license from the respective people, software vendors, in order to make the nodes to work in line. Now, the few extensions of cheminformatics and others. So here you can do some virtual screening, you can do some pharmacophore analysis, some viewers are there. But to be honest with you, these are all a bit old. They're not updating much, but they still works. Then Earlwood, again, you can do SAR analysis if there are any chemist here, and any reactions that you wanted to do, library enumerations, those all can be done here. If you want to calculate some properties like log D, molecular weight, hydrogen bond, donor, acceptor, those all can be done in RDKit. And also you can do clustering and other related geometry related like 2D to 3D conversion, conformational analysis, all those can be done there. Even CDK, where you can do an RMSD calculations, you can depict different connectivity, then Lipinski rule of 5, all those things can be calculated from there. But as I said, there are commercial extensions like Biosolve IT, Chemaxon, Cresset, as well as Mo, then Schrodinger, and others are there. These all, if you want to make use of it, you need to have like paid license from them. Now let's go through data management here. It's very important how to manage your data, right? There are a few main nodes here to understand how to manage the data. There is something else called as group by. Group by means if you want to split the object, if you want to apply a function, or if you want to combine the results, there is a group by function can be used in a particular node called as joiner. What it actually does is, let me show that. Yeah. What it actually does is, let's say we have a row ID G1 to G6. Then we have different group N as two different groups. Then we have values also 2, 3, 4, 5, something like that. Now, I wanted to aggregate them. Aggregate means combine them. So I want to combine all the row IDs are in the group N, and I want to sum them, right? How do you do in Excel? The same way we are doing it here. So we call it as a function called as group by. It's very, very useful when you wanted to split some data, and also when you're doing post-processing of your many biological data, you can do this. The same way, group by node is also there, or in joiner, the groups also can be done where you can do the manual aggregations. Then there is something called as pivoting. In Excel also you have pivoting. Here we are trying to summarize the data with aggregation the column operation operator or a group and pivot, etc. Just a second. Yeah, I'm just trying to load. Yes. So here it tries to pivot the selected columns. In Excel also you do have this option. So what I'm trying to do here is that I have different product ID which are being purchased either online or on site, which is on store. Then I have different category like books, PC, compounds. And I have ordered how many number of compounds ordered I have them. So here I'm trying to aggregate the count because I wanted to know how many books were purchased online and on site. And I wanted to aggregate with the sum, not with the count. I want to know total number of books online purchased and total number of books on site purchased, right? And then again, the total number of PC and the compounds all. So there's a pivoting, grouping, and aggregating. These all can be done in joiner as well as in pivoting nodes. Similarly, there is something called as Pareto ranking. Let's imagine I want to select all the compounds with the 500 molecular weight and hydrogen bond donor less than 5. It will be easy for you to choose them. You sort it, filter it, and then you take it out. But there are some compounds which are having molecular weight 501 and your hydrogen bond hydrogen acceptor is 3. So since one of the properties is not matching, you did not select that compound. Scientifically, it is not correct. They can go into the selected compounds. In that sense, we try to use this Pareto ranking. Here we give the range that I want log P between 0 and 3 or TPS between 0 and 100, molecular weight between 100 to 500. All those I'll give. So they will also filter those compounds only. But that said, they will also do a ranking scoring. They will tell based on these criteria how many compounds can be ranked. Based on that score, you might select the combined ones. Then there are loops. For example, let's say you have 10 different compounds or each row. The particular task that you took, it can run only one compound at a time. So it has to run first row first, go, finish the job, come back and run the second row. Then go and come back and again run the third row. So whoever is using Python and all, you know this if-else loop, right? Same way, if-else loop. Similarly, here we use something called as loop and chunk. In order to handle thousands and lakhs of your rows, if it is running all together, your machine will crash. So you want to split them into maybe 5 chunks or 2 chunks or single chunk. Chunk means, again, in this case, is 1 row or 5 row is 5 chunk or 5 CPUs or 5 core. It's all called as chunk. So then you send a subset of data to your task, what it has to be performed. It finishes that task, comes back again, reads the next 5 subset of data, process it. So it is a looping process. In many sense, it is very helpful. There are types of loops available. This is very, very helpful when you have large set of data. So now let's see how to do data analysis in life science. We have data visualization nodes. There are plenty of data visualization nodes in JavaScript or using Plotly, or even based on Python scripting. In all three different ways, you can do the visualization. And the visualizations are very interactive also. You can do a dashboard interactions. So these are the plots that can be generated within 9. I know you can generate using Python, Matplotlib. You would have using Excel, or you are using GraphPad Prism or Origin, different softwares, but all this is all combined here and free of cost. Similarly, interactive visualizations are this is called as parallel coordinates. If I select some compound, only those compounds will be selected. If I select something on my scatter plot, only those compounds will be displayed in my table. If I select something on my bar chart, those only compounds will be selected on my scatter plot. So these are interactive visualization charts. These are very useful when you're presenting some data during the presentations or while to make some decisions. Any doubts so far? Are you able to follow, first of all, or it is too much?
So
No
this is
response?
very new. So we are trying to connect with you. Like we are trying to follow you the new terminology, and also we are trying to connect with you.
That's appreciated. Thank you so much. But make sure, I forgot to say this. Please don't try to do when I'm explaining here. You just listen to this. If you want to try to do on 9 parallelly, do it with the recording. Don't do it right now. Because no, you will get detached because there are several buttons, several places you have to go. So you'll be getting detached. And coming to the new terminologies, whatever I just took, group by, aggregation, count, summation, these are all coming under statistics for your data analysis, which is irrespective of the field that you're coming from. So they are very useful when you go for your research level of studies because data analysis is the key part of research. You might generate hefty amount of data, but you need to know how to analyze and what to come out of it. Great. Thanks for that. So now coming to the next of the case study, a quick one. What is the time? Oh yeah, we are almost hitting 1 hour. Okay. So there is a main reason for the cause of failure for oral drugs. It's mainly because poor ADME or PK. Around 40.6% of the drugs failed between 1960 and 1980 is just because of poor ADME. Later, when the ADME has been well optimized, there is a new problem now. From between 2000 to 2010, toxicity was having the main issue for the failures, which is more than 40%. This is all I have taken from the below cited reviews. So we need to see how we can optimize this. We can come up with different models which can help us to optimize both ADME as well as toxicity to help us to reduce the failures. There's something called as active learning, which we call it as reinforcement learning, which is there in kind of a AI factor, where it can learn by itself from the mistakes it does, from the good thing it does. Similarly, you can also have experimental data that you have already, including failures and success stories, and then it can learn from there. There are other ML and deep learning applications where we model, design, and optimize, where we can also take structures in smiles, use a property, do the modeling, generate the model using the training cycle by predicting, evaluate, and optimize the predicted value for your new compounds. That's where the QSR, general practice, right? Similarly, the main caveat here is whenever you do projects, please don't use the word AI in your project. I'm very skeptical here. The AI word is too much hyped in drug discovery. Still, if you still say, sir, we hear about a lot of news that AI drugs, none of them yet successful. They're all still, but I have many examples to say what all failed. I'm not being very critical here and not being so negative here. It's only because we don't have enough right data for AI. If you use simply publish data and you say, I have made a AI model, how well you trust that published data? Because for AI or for QSR, we need thousands of data. It's not just 100 or 200 you can do AI. No, you need thousands of data, number one. Number two, that thousands of data should be reliable data. Means if you don't repeat your experiments, wet lab experiments, and if there is no mean median or standard deviation mentioned in your experimental data, that is where you lose your confidence. If you run your experiment only once, how can you say that is accurate? I understand because of the funding limitation, you might have run it only once. But scientifically, you have to run minimum 3 times in order to get the standard deviation error. And that tells you that whether the data is reliable or not. The same with MD also. When I told you molecular dynamics, you have to repeat it. Replicates are important. Each time you repeat, you get different answer. And the clustering of all gives you the confirmed, the clustered answer or data. So every experiment, because in calculator, always 1 plus 1 is always 2. It will never ever change. But in your research experiments, 1 plus 1 can be 1 plus 1 can be 2.0 plus or minus 0.1, 1.9 plus or minus 0.1, 2.1 plus or minus 0.1. All the three answers are correct for me. Absolutely accurate for me. But you have to see that deviation of plus or minus 0.1. That is a valuable data for me. So we need reliable data for AI. When you have a reliable data for AI, go for it. But the question is, do we have enough reliable data? We do, some have, but there are some are proprietary data which cannot be used in the public. So be mindful what you're going to project in your projects. Yeah, putting AI, many people will feel it nice, but please do the right thing. So you can generate data in NIME and analyze also, which is again predicted, not the experimental. How do we generate data within the NIME? That's a beauty here. Let's say you have a structure. You can convert this particular chemical structure into fingerprints. This is what I'm showing you as a fingerprint. Similarly, each fingerprint or each atom group or chemical group can be each fingerprint or a unique fingerprint. This is how the machine understand this is a chemical structure. So in order to understand that, there are basic chemistry nodes within the NIME, which tells you how to input data. So you have a drawing tool like Chemical Sketcher, Structure Sketcher. These are free, but Marvin Sketch is not free. Then there are reaction reader. There are other file readers like reaction reader, SDF file reader, mol2 file, mol file, SDF reader, smiles, directory reader. These are all reader files. Then converter files are there. Mol to CDK, RD kit from molecule. Open Babel is also here where you can convert hundreds of formats. Mol converter is also a converting tool, especially for structures. There are viewers. Marvin View is not free, but ligand viewer, pharmacophore viewer, proteins viewer, and the complex viewer, these are all free. Now let's go through some calculators, chemical calculators. So when you have the fingerprint generator, you can calculate log P, you can calculate a lot of molecular properties, descriptor calculations. So you will see some repeated molecular properties, and because they all are calculated either same property or slightly different property. When you make use of it, you'll get to know. There is a PADL descriptor. I'm not sure whether it works with the latest version, but it was there. And then there are calculate properties on pharmacophore. You can extract all the PDB properties, possibly if you give the PDB ID or Uniprot ID. Analose mold, which calculates all the environmental toxicity, which is listed here. Now, data types is very important, right? So when you come to chemical structure or what type of thing, your data types is an important. Okay, there is a question here. So what type of file formats can be imported into Nine? I think I answered your question already. For example, yeah, these are the files that can be read. I've listed SDF, mol, mol2, PDB, then smiles, a table, CSV, Excel, all those files can be read. Now coming to different file formats, this is again your answer. You can export these different file formats from 9. Mol2, mol, SDF, table, pharmacophore, Excel, CSV, smiles. And there are different data types here. So you can see there is represented by S, I. These are different data types. So here S means string, I means integer. So these data types are very important when you handle steps. This is a workflow that I've generated long time back. I don't know whether I have the data. Yeah, you can see here it is. I developed back in 2018, and not a latest one, but still it works. So here what I'm trying to do is I'm trying to read mol file or SDF file. The top bit, what I'm doing is I'm converting the molecule to RDKit format. I'm adding hydrogens. I'm trying to optimize my geometry by using 3D optimization. I'm just visualizing them and exporting as a 3D SDF. In the second bit, I'm generating 3D coordinates by using a different node, which is like CDK to molecule or CDK. So here it will try to convert into 3D, and then I'm writing a 3D SDF file, and you can also view them. So this is what I have told you about the workflow automation, sorry, animation. So you are explaining to the people whom you are sharing how this is being done, what you have done, and what all things you have to take, what are the limitations in this particular workflow. This will be really helpful. The same way, I built something again back in 2018, very simple raw round, taking an SDF, smiles, and I'm calculating all the environmental toxicity, joining them, and then preparing a CSV file and interactive table. And again, I'm trying to generate a conformer. So I draw a structure and then I add the conformers and I do a energy calculation. Again, I wanted to do a local energy conformer. For example, I have a conformation already predefined. I wanted to create conformations based on in and around of that. So I do a plated conformations also. If I want to do a substructure similarity search, I have an SDF file, which is a database, maybe something that I've taken from my friend or some databases. Then I'm drawing a structure. I converted both of them into fingerprints. I'm trying to compare with this using fingerprint similarity, and I create a distance matrix. And I visualize them how my structure is similar to 10,000s of structures from the SDF. So it will give me a score, Tanimoto combo score, Tanimoto scores will be given there. If I want to generate pharmacophore, I can generate a pharmacophore and I can also align using the pharmacophore aligner. If I want to predict some properties of my SDF file, I can generate using different nodes like molecular properties, log P, descriptor calculations, properties, and many more. These all can be combined and then I can write it as an Excel file, SDF file, or interactive table. This is a bit more complex, but yeah, you can do bit more complex workflows also. So what I have done in this one is I was using version 9 4.3. Now the version is 5.9, so it's pretty old. So what I've done is if I'm giving some Campbell ID, okay, right now it was in Campbell ID. Earlier days it was not working in that database, so I had to do this. So I will be just giving Campbell ID into this particular CSV. It will do a chunk and loop by reading one by one. This is where I use the loop, chunk and loop. Then I'm asking, I'll make my workflow to connect to the online Kembo to pull the data based on the Campbell IDs I've given. So it will pull the data from internet. You need internet for that. I'm specifically extracting only few data from that particular Kembo, including smiles, activity data, and then I convert it and I write it. There are few There are a few manipulations required here because you have to concatenate the data, and you also have to have a rule-based splitter based on the missing Campbell IDs. So these are all you can automate it. So the only input I have given is CSV. It will go online, download the data. It will change the way I wanted the format. It will identify missing data. It will let me know what all are missing, and it will write the data. So if you're doing it manually, how would you have done? You have gone, upload a CSV file to Campbell. It will give search everything. You will download an SDF and use it and filter them manually. But this can be automated here. Again, machine learning based QSAR, where I have my data. I use the X partitioner to do split my data. So I take a training set, which is my trainer, a learner, and then for the prediction for the test set, then I do a linear regression. Then I aggregate them to understand what are my SD plots and others. The same, I can assess whether my models are really good or bad by looking at domain leverage, domain similarity, and applicability domain based on different criteria. These are some of the citations where I've used this content, to prepare the slides. So you can also refer them. So that's all from me, but I'll quickly show you some demo. If before that, do you have questions? I know it is new to you, but you can always ask the questions like what kind of job or what kind of applications it can do. Because here we are here to learn new things, which is for to make you job ready and research ready, right? Because tomorrow when you apply for your CV, you can always mention you know nine, and you will see in coming days that in what to say in job description you will see nine as one of the skill you should know. Yeah, Shiva.
So how are results or any kind of statistical analysis can be studied in nine?
Yes. Have you heard about a package called as Veka?
No, sir.
Heard about R?
Yes, sir. It's a programming language.
Correct. So R, Py, and Veka. These three are already implemented fine. So you can do any statistical analysis either using Veka, including machine learning, or R. So R, of course, you need to know a bit more of scripting there, R language, but Veka is a drag and drop. You can easily do it. I'll show you in a bit. Any other questions?
Sir, how does NIME helps in data science?
So data science, data engineering, data analysis. In these three different areas, they do help. One, as I told you, data manipulation, as I showed you, data group by missing values, analysis, right? Pivoting, then aggregation. These are all data manipulation. Coming to data science is when you're trying to model something with the data and how productively do you make use of that data. So you have all machine learning algorithms, even your PyTorch, Kera, H2O, all the algorithms for your AI, these are all embedded there in it. You need not to write a single line of code to do any of these activities. So the best benefit of NIME is it is not mandatory that you should know coding. So that's how it helps with data science. And of course, data analysis where you can go for visualization, right? So you as I showed you some lot of visualization, you will be able to do visualizations. Any other questions? Okay. Let me go quickly back to NIME and then I'll show quickly one example and then we can wind up the session. Okay, so I'll go to home. In my local base, I have some examples. right? So it's a demo 25 Jan. This is something I showed last year. So I'm still having the workflow that I showed for your previous batch. So here I have a CSV file. If I click on it, if it is already being read, it will show me the data. This is because I have already read it, but I'll show you how to read and all those things. So when I drag and drop, I can search here CSV read, I drag and drop, right? Then I click on this arrow and then drag it and take off my mouse. Then I can type whatever I want to type. So if I want a um, column filter, I can get that. This is a build the notes. If you want to delete, you can delete. Press send delete. Okay. Now, to give you a bit more example, how did I configure this? You double click on it. So I just told what is my Excel file or CSV file. And this is what I was trying to tell you in my presentation about the local file system mount or relative to and all. So I just went for local. And then I can do, being it is a CSV, either it can be comma separated, tab separated, semicolon separated, several. So you should know what is the delimiter. So based on that, you will give those data here. Then you can come to transformation and you can reset the action or enforce the type. So if you want to change the type of data that is there. So for example, yeah, because it is not exist, that's why it is showing error because I've changed the file path. And it can also read up to what level it can go. And now if I go to column filter, what I'm going to say is that my CSV is having a lot of data here. I don't want all of them to go to my next thing. So I'm going to remove some. So I removed synonyms, type, and max face from my CSV that I have read. Then I'm going to sorter. Sorter means I want this column to be first, this column to go to last. So all those things I can do, and also sorting the column by itself. So if I want to sort based upon log P in an ascending order, I can do that. In the second criteria, if I want a molecular weight to be sorted, I can do that in order. So these things can be well defined in the sorting. And after that, I'll be able to visualize my data using parallel coordinates plot. And you can see at the bottom. This is a plot which is telling me, okay, these are the compounds which are having the property within this range. So if I select them, if I'm saying that I want to see the bioactivity between 1 and 2, I can see only few structures with them. But by generally it is showing everything, right? Earlier it was showing everything. I had many structures here. But I want to see only few with that particular property range, I can always do. And I want only compounds with the log P less than 5. And I will take this away, right? Or I can take till here and this extend it. So I'm extending it. Even though I extended, my log D is still not in that range, right? So this is how you do the post-processing analysis. Even though I have a good activity there, but I don't have good log P. So since the log P is not great, I cannot pick them. And I also want my hydrogen bond acceptor to be less than 5, right? So these kind of analysis can be done in your interactively on your parallel coordinates. The next is that interactive slide filter. So I can filter the slide. I'll come to that a bit later. And then I have a scatter plot. In the scatter plot, it is plotting my whatever I wanted to do. And if I select them, those will be displaying what is the ID. So this is an interactive plot, which I don't think you get it on your statistics packages and all because they're a bit different. Even there are plots which will show you the structure itself instead of the ID. And then I can look at a heat map, which is showing me a heat map. Now, all these things I can see this all together. So what I'll do is if I select all, and if I say create component, and I create them. So this is a component here. Yeah, this is a component here. I just run them. And if I open this component, open the view, you will see it as a dashboard now. It will load. I just look much better aligned, and all I did not do. Now I did it on the fly, right? So this particular scatter plot heat map will change now if I change my slider, and I have to apply refresh it. Yeah. Yeah, I think most of the properties within that limit, the scatter plot got changed. So anything after that particular slider, they get they get reflected the downstream. So here also, if I'm looking for only these many compounds, how many compounds are having lower log P? Only these many compounds are having log P. So this is a interactive dashboard which I can get everything in one go. You can export it as PDF. You can export it as a high quality images. This is all possible. Then what I'm doing is I'm writing this as an Excel sheet. So all the data, whatever the properties are there, it can be gone to Excel sheet. We can do a bit more also. If you want to calculate a property from RDKit, or if you want to do any others, you can still do a group by, or like in the aggregation I showed you. So based on what you want to group. So let's say I wanted to group based upon number of hydrogen bond donors. If you want to have a manual aggregation, you can do that. Or if you want to get the count, you can do that. So if I say I want to know the count from the Campbell ID, and I'll say I won't just know the count. That's it. Where is it? Yeah, unique count. And I click OK, and I run them. So at the bottom, you can see I have hydrogen bond donors with the 5 hydrogen bond donors. There are 2 compounds which are unique. Um, without the hydrogen bond donors reported, there are 15 compounds in my list. So this is the way you do your data analysis to understand what are the different hydrogen bond donors I have, how many number of compounds I have in this list. It's a small trimmed set, so you won't find too many. So these are the kinds of analysis that you can do in the 9. And that said, since many of you told me that it's all new terminology, please make use of this 9 AI assistant. So it will be useful to start get you going. Yeah, that's all from me. Any questions?